Good morning, everyone. I believe you are all well. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, I want to take you through mathematics for paper 2, particularly on statistics, which I will be focusing on the ungrouped data. So this will be regarded as part 1, which means we're gonna have another session for a grouped data for statistics. Then the last one will be based on regression. I believe you are all well. Right, for part 1 and part 2, this will the target audience will be both grade 11 and 12. So stay tuned and enjoy the session. Kindly don't forget to like, subscribe, and hit the bell button for future video notification. Right, without wasting time, guys, I want to take you through the statistics for ungrouped data, particularly by looking at the examples. Right, now we have one activity which will enable us to address all the concept behind ungrouped data. Right, without wasting time, let's look at this question. It says a survey was conducted to determine how people feel about quality of programming available on television. Respondents were asked to rate the overall quality from 0, which represent no quality at all, to 100, which is extremely good quality. Right, the stem and leaf plot or the stem and leaf display of the data is shown below. Like, let's look on our stem and leaf plot, ladies and gentlemen. Remember, a stem and leaf plot is just a way of arranging numbers from smallest to highest without having to identify or to cycle point by point. Right, when we look at our stem and leaf plot, already the numbers are arranged from smallest to highest. The first one, we have 32, 39, 40, 43, 44, 47, 48, 49, 49, 49, 50, 51, 51, 51, and so on. Right, then now with the highest number, which is 96, the numbers are already arranged from smallest to highest. When we look at this, we do not have 80 something. Right, according to the information, the first question says, calculate the mean of the data. Since we are dealing with an ungrouped data, remember, what do we mean when we say the data is ungrouped? It's ungrouped because it's not grouped according to the interval. So if it was grouped according to the interval, for example, if you say numbers that are between 0 and 40, numbers that are between 41 to 59 or 49. So this will be an example of a grouped data. So now, for now, we're dealing with data that are not grouped according to the interval. I believe you are following. Right, the first question says, calculate the mean of the data. We know in statistics that when we calculate the mean of the data, especially for an ungrouped data, we use the following formula. The mean, which is the x bar, equals to the sum of all observation divided by the number of observation. So what we're going to do here, we have to calculate the mean of this data. And to do that, we have to add all these numbers. We divide by the total number of this observation. And to do that, guys, it's simple. We just use our financial, our Casio. If you have a Casio, then, or any calculator that is non-programmable, particularly for grade 12, then it can enable you to answer the question. All right, on my side, I have a Casio. And then what I will say, first we'll go to mode. On your calculator, you go to mode, you press mode. After mode, you have to go to stats. I think on most of the functions or on most of the calculators, it's number 3. I'm not unless if the calculators are different. Then you first go to mode. Then after mode, you go to stats. You press stats because we are now dealing with statistics. After statistics, it will take you to, you'll first go to one, which is one var, because now we're dealing with a univariate data set. So you press one var. A one var will give you a table where you'll have to insert this value. So you're gonna press one for one var for one variable. So what you're gonna do, you have to press these numbers. You insert these numbers inside your calculator while pressing an equals to. So the first one will be 32 equals to 39 equals to 40 equals to 40, 43 equals to 44 equals to 47. You press equals to 47, 48, 49, 49, 49, 50, 51, 51, 52, 53, 54, 55, 61, 62, 65, 66, 66, then 71, 79, and the last one it's 96. Then already after you have entered all the values in your calculator, you have to press AC. You just press AC, or even delete, just press AC button. If you press the AC button, then it will close the screen. Then after doing that, you have to press Shift. You press Shift, and after pressing the Shift, then simultaneously you press 1, the button for 1. Then why doing this? Because on the button for 1, there is a part for statistics. So you press Shift and 1. Then after pressing Shift 1, it will have 6 options. Number 1 is the type. Number 2 is the type of the data that we have inserted. Number 3 is the sum. Now we want the sum because we want to get the sum of X here. So we're going to press 3 for sum. Then from the sum, it will show 2 things. It will show sum of X squared and sum of X. Now we want sum of X, not sum of X squared, because this one, it's the sum when the values are squared. So now you're going to press, I think it will be 2, then you press equals to, and the sum of X will be 1,372. Then you divide by how many data here? There are 25. So you can still get this. Then you can also say, to confirm the X bar, Shift 1, then you go to variable this time, you go to var, then you press number 4. In number 4, you'll see we have n. N is the number of observation. 2 will be this X bar. The number 2 will be the X bar. It depends on the calculator. If you press that 2, it will show you that the X bar or the mean is 54.88. So you have to show this. You can also say 1372 divided by 25. It will still be 54.88. You need to show all this working sometimes, because if you just write the answer only, you find that there are marks for just adding. So you need to make sure that you understand how to do this. Then 1.2, it says calculate or write down the value of the median. Right, we know that the median is a quartile. It's actually quartile 2, which in other book we call it the 50th percentile. It's called the 50th percentile. So now, since it is in the 50th percentile, then we have to actually calculate its position. Why are we saying it's the 50th percentile? I apologize. It is in terms of its position, it is 50% away from the minimum when we have arranged the data from the minimum to the maximum. So first of all, we need to calculate the percentile or the quartile 2 position, which is we need to first calculate the position for quartile 2, which is the same as just saying, since we have a 2 here, this will be 2/4 multiplied by n plus 1. And what is 2/4? 2/4 is the same as half multiplied by n plus 1, which is the same as 50 percentile, because when we say 50th percentile, this is the same as 50 divided by 100 multiplied by n plus 1. For example, if we say calculate the 85th percentile, the 85th percentile is just 85 over 100 multiplied by the n plus 1. I believe you are following. So it means in this case, we need to calculate the position for quartile 2. Remember, you cannot calculate the median if you have not arranged the data from smallest to highest. Now, to do this, we're going to say, okay, fine. In terms of calculating the position, what will be the position for quartile 2? Then how many observations are we having here? We're having 25 observations. So we're going to, where there is n, we're going to put 25. So this will be 25 plus 1, which becomes 26. And what is half of 26? Half of 26 is 13. Half of 26 is 13, which means now to calculate the quartile 2 or the median, to calculate the quartile 2 or the median of the data, we have to count from the lowest up until to position number 13. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it means 51. It is our median because the numbers have been arranged from smallest to highest. I believe you guys are following. I believe you guys are following. All right. Then now, without wasting time, let's now move on to the next question. The next question, it says, write down the mode of the data. Write down the mode of the data. Remember, you cannot calculate quartiles, particularly quartile 1, quartile 2, which is the median, and quartile 3, if you have not arranged the numbers from smallest to highest. Right. Then now, the next one, it says 1.3. Write down the mode of the data. We need to write down the mode of the data. And ladies and gentlemen, what is a mode? A mode is the number that occurs most frequently in a data set. The number that repeats itself or the number that occurs most frequently in a data set is called a mode. When you look here, we only have one number that occurs most frequently than the other, which is actually 49. It's repeating 3 times. As compared to 66, it's repeating twice. 51 is repeating twice. So it means this is the mode here, it's 49. The mode is 49. The number that occurs most frequently in this data set, it's 49. The number that occurs most frequently in a data set, it's 49. I believe you guys are following. This is an example of an ungrouped data. Right, then the next one, it says 1.4. It says calculate the standard deviation. Calculate the standard deviation of the data above. We need to calculate the standard deviation of the data above. Right, in terms of your syllabus, when we calculate standard deviation, we consider this the sigma x, which is a population standard deviation. We do not use a sample one in terms of your syllabus. So which means that to do this is easy. Since we have entered the values in our calculator, like what I've shown you earlier, then it means the values are still there in the data. In the memory. So what you do, you say you still go to shift, you press shift, then you press 1, shift 1. But then remember on the one there's this stat in orange. Is it orange in yellow? So now, once you press shift 1, it will take you back to the information. Right, 1 is for type, 2 is for data, 3 is for the sum, 4 is for the variable, 5 is the minimum or maximum. It depends with the calculator. But this time around, we want var, variable. So you're going to press the information for var. So on the information for var, if you press 4 there are 2 things which you need to consider. We have with this symbol, sigma x and xx. So in terms of your syllabus, we do not use XX. This is a sample standard deviation. So it means you have to use this sigma in terms of your syllabus, which is a population standard deviation. So we do not use the S. You learn more when you continue with statistics. So this is called a sample standard deviation, and this is called a population standard deviation. So now we're gonna use the population standard deviation. But however, in reality, we're supposed to use sample standard because the data it's sampled is not actually for the whole population. But now in terms of your syllabus, we only use sigma X. So now we're going to press that will be number 3. Then the sigma X will be 13.43. 13.43. So it means our standard deviation is 13.43. Remember, all the time, we do not use XX in your syllabus. We use sigma. You always consider this. I believe you guys are following. I believe you're following. Right, now we move on to the next question. Moving on to the next question. Okay, I apologize. Move on to the next question. The next question, it says, how many of the data they lie within one standard deviation from the mean? How many of the data lie within one standard deviation from the mean? And these are exam typical questions. Right, number 1.5. It says how many of the data, so it means you have to count, we lie within one standard deviation from the mean. How are we going to do that? There is a formula to do that, which says the mean plus or minus k times the standard deviation. The mean is equals to the mean is plus or minus the k times the standard deviation. So if we expand this will be the mean minus k times standard deviation, and the mean plus the k times standard deviation. So when we say when they say how many of the data they lie within one, if they say within one, it means that the k factor, it's 1. So it means when there is k here, we're going to substitute by 1 because it says within one standard deviation. If they say within 2 standard deviation, it means now we're going to substitute by 2. So what is our mean value? The mean value, we know it's, the mean we calculated it's 54.88. We just calculated the mean, or the X bar, 54.88. So this will be, what is the mean? 54.88 minus the k, it's 1, which means it's going to be 1 times standard deviation. We have it's 13.43. Then same applies, 54.88 plus 13.43. I apologize, it's 13.43, not 13.45. So let's do the subtraction. 54.88 minus 13.43. So this will give us 41.45. And the other one, it's 54.88 plus 13.43. This will give us 68.31. But the question says how many of the data they lie within one standard deviation. So once they say they lie within, it means we need to look on this data and we look at the ones that are falling between 41.45 and 68.31. But however, we need to round these values to the nearest. If we round 41.45 to the nearest, this will just give us roughly 41 as the minimum. And 68.31, this will be just roughly 68, which means that we are going to count, or we look at the values that are falling between 41 and 68, not outside, because if they said outside will be below 41 and above 68. But the question says how many of the data they lie within one standard deviation, which means within this data, we are going to count this one, the numbers that are falling between 41 and 68. So if we look here, The numbers that are ranging between 41 and 68, the first one is 43, 44. So it's 43, 44, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it means the maximum will be 66. So the answer is 19. It will be 19 observation or respondents, because here there was just the issue of respondents, the number of respondents. So it will be 19 respondents. The 19 respondents falls within one standard deviation. But sometimes they can say what percentage of the data. So it means in terms of percentage, you're not going to say 19, you're going to say 19 out of 25 multiplied by 100. I mean in terms of percentage, if they say what percentage of the data, right? This is how we answer the question, right? Without wasting time, let's move on to the next question. And the next question says, what percentage? You see now they're talking about percentage. It says what percentage of the data lie above one standard deviation? What percentage of the data it lies above one standard deviation, but in terms of percentage? Since they're saying it lies above one standard deviation from the mean, it means we're still using the same information, but this time around we want the ones that are falling above one standard deviation. And how are we going to do that? It means we are not interested on the one that is falling below. We are interested on the one that is falling above, which means this time around we want the upper limit, not the lower limit. So it means if we're not given the first question, we're going to consider only the mean plus k times the standard deviation, which is just the SD, because the k is 1. Then which means in this case, since we have already determined this is the same information, it means if we're not given that, we're going to say 54.88 plus 13.43, which is actually 68.31, which means we now want the ones that is above this value, the ones that are above 68.38. Values that are above 68, which one is that? It will be 71, it will be 9, and it will also be 71 and 79 and 96. So it will be 3 of them, 3 respondents. But in terms of the question, it says what percentage. So it means we want to write that as a percentage. So this is 1.6. So it means it's going to be 3 out of 25 multiplied by 100, because they want it as a percentage. So it will be only 3 respondents out of 25 multiplied by 100, which will just give us 12%. If I'm not mistaken. So it's only 3 observations that are above one standard deviation, that which are above 66. So 3 out of 25 multiplied by 100, that is the answer. I believe you guys are following. All right, without wasting time, let's move on to the next question. The next question says, how many of the data now they lie within 2, they lie outside, I apologize. How many of the data they lie outside 2 standard deviation, outside 2 standard deviation? This time around, we're looking at the ones that are outside. Outside means can be below or can be above. It's not within. So the ones that are with the ones that are falling below 1 standard deviation or above 1 standard deviation. So how do you do this? This time around, the K has changed. We're not going to use the K of 1. Let me say, yes, the K of 1. We'll use the K of 2. So now, let's now do the working. Let us now do the working. I believe you guys are following. Kindly, if you want to try it, just pause the video and do it on your own. Then after doing it on your own, then you will confirm the answer. You'll confirm the answer that I'm going to provide right now. So 1.7, now we are dealing with, we want the ones that are falling either below or above. So it will be the mean minus K. K this time around is 2. So it will be 2 SD, and the mean plus 2 SD. I believe you understand why I'm now including 2, because it says within 2 standard deviation, outside 2 standard deviation. What is the mean? The mean is 54.88 minus, so we're gonna say 2 multiplied by the standard deviation we have is 13.43. 2 multiplied by 13.43. This will give us 26.86. Even this side, this will be 54.88 plus 26.86. I believe you are following, like you understand how I got the answer. Right, then now this will be 54.88 minus 26.43. It will be 28.02 followed by, okay, let me open the brackets here, right? Then we're gonna have same applies. I'm gonna add now instead of subtracting. We start with the minus first. So it's gonna be plus, this would be 87.74. And if we round this to the nearest, remember, you have to leave the answer like this in the exam. So if you round this to the nearest, that's what I'm doing somewhere. Let's do it somewhere. Let's round that to the nearest. We'll have 28 and 88. So it's roughly 88. So what do we want here? We want we want to count the data that are lying outside. So outside means we want the ones that are below the minimum and above the minimum. So it's either below or above. So it means now we're counting the ones which are below 28 or above 88. So if we look here, none of the numbers are below 28 because the minimum is 32 and 32 is part of the interval. But how about which are above this side? The numbers that are above 88, it's only 96. So it's only one. So one respondent. The answer is a one respondent. So it's only one respondent which is lying outside 2 standard deviation from the mean. I believe you are following. Remember, they did not say as a percentage. They did not say as a percentage. So I believe you guys are following. They did not say as a percentage. So in that case, it means we count by just doing a counting. It's only one respondent which is falling outside 1 standard deviation. And guys, this is an exam typical question. You need to make sure that you understand this. Practice makes perfect. Practice makes perfect. Right. Let's now continue. We're now going to continue with the next question. Let me just try to erase here. And please kindly don't forget to like, subscribe, and hit the bell notification for future videos. Right. Without wasting time, we have calculated all the information. Now let's move on to 1.8. Right, 1.8, it says calculate the interquartile range of the data. We know when we are calculating the interquartile range of the data, we take the upper quartile, which is quartile 3, and we minus the lower quartile, which is quartile 1, which means to calculate the interquartile range, we have to get quartile 1 and quartile 2, which you need to first arrange your numbers from smallest to highest. But since they are arranged, then we can just go straight to the calculation. So quartile 1, which is quartile 1, we need to calculate its position. Remember, quartile 1 from the data, it is positioned, it is a 25 percentile. It is 25% away from the minimum. So it's a 25 percentile. And how do we deal with 25 percentile? It's 25 over 100 multiplied by n plus 1, which is just 1 over 4. But if you forget this, what you do, you just look at this. Since you say quartile 1, just say 1 over 4. Just take 1 and divide by 4, and you add with n plus 1. So what is the n? We have 25 observation. 25 plus 6 plus 1, this gives us 26. So it's a quarter of 26. So 26, a quarter of 26 will give us 6.5. 6.5. So it means now the value of quartile 1 will be between 2 numbers. It will be between 2 numbers. So how do we do this? means it's going to be between, because it's position 6.5, it's going to be between position 6 and position 7. Okay, then how do you do this? Since here is just say 6.5, it means you're going to count at number 6 and number 7. So it's 1, 2, 3, 4, 5, 6. 6 it's for 47 and 7 is 48. So it's 1, 2, 3, 4, 5, 6, 7. So it means it's between 47 and 48. So we're just going to add the numbers 47 plus 48 divided by 2. So this will give us a value of 47.5. 47 plus 48 divided by 2. This one will give us a value of 47.5. But in reality, ladies and gentlemen, when you go to university, we're going to use something called interpolation. We're using interpolation to say, to calculate quartile 1, we take, since it says 6.5, we're going to take the value that is at position number 6 plus the remaining percentage, which is 0.5, then times the one that is at position number 7, we subtract the one at position number 6. So the one at position number 6, it's how much? It's 47, and the 0.5 times the one at position number 7, it's 48 minus 47. Then this will still give us 47.5. But in our syllabus, we do not use this interpolation, because this will be 47 plus 0.6 into 0.5 into 48 minus 47, which will still give us 47.5. But in terms of the syllabus, it's not shown in most of the textbooks, so we're not going to use this. Right. Let me not confuse you guys. Now, from here, we'll have to calculate the quartile 3. Quartile 3, it's the upper quartile, which is the 75 percentile. Actually, no. We have to calculate the position first. Right? We call it the quartile 3, which is the 75 percentile. And 75 percentile is the same as 75 over 100 into n plus 1, which is just the same as 3 divided by 4 multiplied by n plus 1. So which is just 3 over 4. What is the n? N is 25. 25 plus 1 is 26. I believe you are following. So 3/4 of 26. So 3 over 4 times 26. This will give us 19.5. Means here the quartile 3 is between position. It's between number 19 and number 20, because it says 19.5. So we're going to count up until position 19 and 20. So remember, we said this is number 6. This one is number 6 here. But we can recount 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So it's between 62 and 65. So since it says 0.5, then it's going to say 62 plus 65 divided by 2. So we're going to have 62 plus 65 divided by 2, which will just give us 63.5. This is our quartiles. And since we have our quartiles, ladies and gentlemen, now we'll have to calculate the interquartile range. Let's now calculate the interquartile range. I believe you guys are following. Right, let's now calculate the IQR, which is just the quartile 3 minus quartile 1. What is quartile 3? Quartile 3, it's 63.5. You must write this. You must show that this is a position, because if you don't just write the position, you think that this is the quartile. Right, then quartile 1 is 47.5. So 63.5 minus 47.5. I think this will give us roughly 16. So in the interquartile range, it's 16. So we have the interquartile range of 16. I believe you guys are following. You must know the positions. Right. The next question, it says, now write down the 5-number summary of the data and construct a box and whisker plot. We need to write down the 5-number summary of the data and we use this to construct a box and whisker diagram or plot. To do this, we're going to write down all the 5-number summary. Remember, 5-number summary, it requires you to write down the minimum. You must have the minimum value, the lower quartile, which is quartile 1, and the median, which is quartile 2, and the upper quartile, which is quartile 3, and lastly, you must have the maximum. So it's minimum, lower quartile, median, upper quartile, maximum. Already the minimum is 32. Then the lower quartile we have calculated now it's 47.5. And the median, the median we got it to be 51. Remember, it was at position 13. Just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is 51. Then the quartile 3, we got it here, it's 63.5, 63.5. And what is the maximum here? The maximum is 96, which will be regarded as an outlier, this one. But we'll talk about that. So now, without wasting time, they said we need to write down the 5-number summary, and at the same time, we construct a box and whisker diagram. Right, remember, in terms of the box and whisker diagram, we can still comment on the skewness of the box and whisker diagram by looking at the mean of the data and the median of the data. But which we're going to talk about that. Right, let's construct a box and whisker diagram. Remember, usually in the exam, if they want you to construct a box or whisker diagram, they'll give you a graph paper which has all the relevant values, so that you'll be able to draw a nice one, because it will be scaled. Right here, I'll just do this. Okay, let me just draw a nice one. It's still the same thing. Okay, no, it's fine. So let's just do this. Okay, let me just draw it for the last time. Okay. No, I'm shaking. Right, so let's create a scale. The minimum is 32, the maximum is 90. So let's just say maybe we have an interval of 0, 10, 20. Yeah, I know there's a gap there. 30, 40, 50, 60, 70, 80, 90, and 100. Right, let's do this. We're now going to plot our box and whisker diagram. So let's do this. What is the minimum? The minimum is 32. So if you have 30, so 31, 30, 32, usually can use a ruler, right? Yeah, 31, 32, 33, yeah. Let's just say 32 is somewhere here. Okay, then now how about the quartile 1? Quartile 1 is 47.5. So let's say somewhere here it's 45. Somewhere 45, 46, 47, 48, 49. So 45, 46, 47, 46, 47, 48.5. Let's just say it's somewhere here. It's just an example. Then what would be the quartile 1? Quartile 1 is the minimum, median. Median is 51, somewhere here. Then what do we have? Quartile 3, 63.5, 60, 61, 62, 63, 63.5. Let's just say it's somewhere here, if I'm not mistaken. I believe you guys are following. Right, then now the maximum is 96. 95 is there, 96 somewhere here. Let's just say that it's 96. So we're going to first join the box. Remember, this quartile 1. We join a box on the quartiles first. So this is our box. Then now we join the whiskers, construct the whiskers. So this is our box and whisker diagram. Right, then now this is our box and whisker diagram. And right, by looking at these guys, we can be able to comment on the skewness, because usually if we have this kind of scenario, you can easily see that. Remember, this is the minimum. This is the Q1, and this is the Q2. This is the Q3. 3, and this is the maximum. So let us look on the question, the next question, before I start answering that. The next question says, comment on the distribution. Comment on the distribution of the data. Right here, when they say comment on the distribution, it means they want you to tell them in terms of the skewness, whether you want to have skew to the right, skew to the left, or symmetrical. But by looking at this, look at this on the box. This is the left part, and this is the right part. Let me use a different color here. So this is the left part, and this is the right part. Now, if you look at this, where do we have more space? More space is actually on the right, so which means this is actually skewed to the right. So this is skewed to the right. It is skewed to the right. Or if you didn't want to say skewed to the right, you can say positively skewed. Positively skewed. Remember, even if we do not construct a box and whisker plot, by just comparing the mean and the median, if the mean is bigger than the median, usually, if the mean it's actually bigger than the median and even bigger than the mode, but usually let's talk about median. If the mean is higher than the median, you know we have skewed to the right. But if the mean is less than the median, then it's skewed to the left. But if they're equal, then it's symmetrical. Why am I saying this? What is the mean of the data? The mean of the data we calculated as 54.88. What was the median? The median is quartile 2, is found to be 51. Do you see that the median is bigger than the mean? Let me say the mean is bigger than the median. So this is skewed to the right or positively skewed. Right, the last question it says, okay, just a minute, guys. Okay, the last question says, identify outliers with the aid of calculation. Ladies and gentlemen, outliers are extreme values that are far much away from other. So by looking at our data, even if we not like, since here they said we need to just identify by means of calculation, the outlier, it will be 96. But since they said we need to show by means of calculation, then we need to actually do the calculation as we are instructed. But actually the outlier will be 96 because it's a value that is far much away from other. Right? There's a formula of identifying outliers. The formula for identifying outliers, we have to calculate the fences. We have what you call the lower fence. So first of all, we're going to calculate lower fence. Okay, I'm supposed to use the same color. So let's just use the same color. So we're going to calculate the lower fence. The formula of calculating lower fence, it says quartile 1 minus 1.5 times the interquartile range. So what is the quartile 1? Quartile 1, if I'm not mistaken, we got it to be 47.5 minus 1.5 quartile range, interquartile range is 16. So we can also calculate the upper fence. The upper fence, we use the upper quartile. So it's quartile 3 plus 1.5 times the interquartile range. So what is the quartile 3? Quartile 3 is 63.5 plus 1.5 times 16, if I'm not mistaken. So let's get the lower fence and the upper fence. So it's 47.5 minus 1.5 into 16. Then this will give us 23.5. Then secondly, we have 63.5 plus 1.5 times 16. This will give us an upper band of 87.5, which means as a fence, the lower fence will be 23.5 and the upper fence will be 87.5, which means any value that is not falling in this interval, it's regarded as an outlier. And what is the minimum here? The minimum is 32. It's part of this interval. What is the maximum? Is 96. 96 is not in the interval. It's outside 87. So it means an outlier here. We only have outlier. And our outlier here, it's 96. So 96 is an outlier because it's not falling in the interval. Remember, ladies and gentlemen, practice makes perfect. Practice makes perfect. Don't forget to like, subscribe, and share. Thank you very much. Take care.